Okay, so here we are going to solve a problem like this. This is also a connected block problem. You have two objects, M1 and M2. They connect with each other by a rope. So when you solve this kind of problem, that means you have two blocks, and then each one of the block will have different uh, force acting on each one of them. So the first thing I would do is to use the free body diagram. So let's do a free body diagram, and we're going to do this one on the M1 first. So here is our M1. And think about this. If you have this one here, what other forces is going to acting on M1? Now always, when an object has a mass, it always has a weight. So this is the weight of M1. And the weight of M1 is going to be equal to the mass of 1 times G, where G is 9.8. Now I see a lot of people make mistake in this way. What is the mass of M1? Do they tell you about the mass of M1? No, they didn't. They tell you the mass of M2. So this one here is 19.0 kilogram. This is not equal to the weight of block 2. A lot of people just take this one as the weight. This is a mass. This is not weight. If you do that, you're going to get some points off. Don't use the mass as the force. You have to multiply with the G. That's an order of 10. So this is like an order difference. So you have to multiply almost like 10 to get the weight. So this is the first force on this one here. The second force is coming from the rope. We just told you in one of the video that we show you, when you have a rope, the rope is going to give a force. Now the rope is a tension force always going outwards, is always going away from the object. So this is the tension force. Okay, now this is a sand rope. So if you have a tension force here, which is a T, then anywhere along the rope, the tension force will be the same. Okay, so this tension force always going to be the same along this rope. Which means on the other end, if you analyze this block, you are always going to have the tension force as well. And again, the direction is going away from the object. This is going to be the T. So this T is the same as this T over here because it's the same rope. If the rope doesn't have the same tension, that means the rope is broken. Because it's the same rope, it should have the same tension. Right? If one side of the tension is larger than the other side, it's either they're moving, the rope is moving, or you are going to take it apart. The rope is going to break. So that is there are like two forces. Are there any other force acting on this object? Do we have a supporting force from this wedge to this block? The answer is no. There's no force coming from here because they're not touching with each other. Unless they're touching with each other, like this one here, then there's no supporting force. So this is the block, the free body diagram of this one here. If I look at this, and the next thing you do is, once you have the free body diagram, you need to write the equation of motion. And what is the equation of motion? That is the net force equal to mass times acceleration. Okay, so I already find this, but when you write this, because the force r vector, then you wanted to specify the direction. So the way that I like to specify the direction is I'm going to draw arrow on the left of this thing, this equation. And I like going upwards to be positive, so I will say my direction of motion, in this case, either go up or go down. I will make go up to be positive. Okay, so if this is a positive, then how do you write the summation of force? Do I have a force going upwards? The tension is the force going upwards. I have another force going downwards, which will be negative. So if I write this, I will say, okay, T is positive, the W1 is negative because it's going downwards. And there's only these two forces acting on the object. And what will be the result? The result will be the mass. Now, what is the mass in this case? It will be the mass of the block that you're looking at. So this will be the M1. And you're going to multiply with an acceleration, which we don't know what that is. If this one moves, what do you think the acceleration direction is going to be? The acceleration will also going upwards if the net force is upwards. Okay. If the weight is heavier, that means this block is going downwards. If the tension is larger, then this block will go upwards. Okay. Do I know which way it goes? Do they tell you? No, they didn't in this case. I'm going to just assume, this is the direction, then it will be positive. So part of the problem, probably they will give you more information for you to solve that. Alright, so the other thing we're going to do is we're going to look at the block 2. So let's look at the block 2. Let's use a different color to represent the block 2. Oh, it needs. Let's look at the free body diagram on the M2. And I'm going to use another color. This is let's use yellow. So M2, what are the forces acting on the M2? We have a weight, right? As I told you, always if you have a mass, you have a weight. So this is a weight 2, W2. And you have a tension force over here that we drew before. So there's a tension force. Are there any other force acting on this object? Well, yes. The block and this ramp touch with each other, so there is a normal force or the supporting force from the ramp to the block. So this one I will write an N over here. Okay, now if you look at this one here, you have T, you have N, you have W2, and you have 3 different forces. The question here is that how do you analyze this? How do you write the equation of motion like this? Okay, that will be the challenge part for some people. So let's look at what is the equation of motion. Okay, a little bit lazy and just write equation of motion in this way. When you start to write equation of motion, you have to define your coordinate. So in this case, I'm going to use an angled coordinate system. So I'm going to define my coordinate in this way. I'm going to make the direction along the slope to be the x. The direction perpendicular to the slope will be the y. And then I'm going to analyze the force at the two different directions. I'm going to look at the net force at the x direction, and I'm also going to look at the net force at the y direction. What is the result if you actually have a force? And you look at this block. If there is a net force in the x direction, then this one will move, and it will move along the x direction, right? And let's say this direction is going to be my positive direction. So I'm saying going to the right is going to be, it's not exactly the right, but it's, going along the slope downwards is the positive. What about the y? The y is that if you go this direction, you are going to get the positive direction. Okay, so I make this one positive, this one positive. I don't know if this block actually moves to the right. It could move to the left, unless you know the mass, right? If this one, so if M1 is heavier, then you are going to expect the block 2 is going to move upwards. So it's going to move left. Alright, so what is the result if you have a force? If you have a force along the x direction, I know it's going to have the mass times acceleration. This mass is the mass 2, because I'm looking at the second mass. And this will move with an acceleration. Okay. What about y? In this case, we are going to make this one equal to 0. And I make it equal to 0 because I am not expecting this M2 to jump up and down at here. Because there's no room for the M2 to going downwards because it's supporting by the slope. So unless this one fly out, which we don't allow it to fly out in this case because it's connected with a rope. So you can write this one equal to 0. Okay, now how do we analyze this the force? And let's look at this picture here. What are the forces acting on the x direction? We have the T at here. We have certain part of the weight is going to be in the x direction. So what are the amount of the weight in the x direction? So if you look at the weight, I can decompose the weight into different direction, right? So some part of the weight going to this direction, some part of the weight going this direction, such that if you sum these two will be equal to the weight. So I will normally write this one as the W2 comma x represent, this is the x component of the weight 2. And this one here will be the W2 comma y, because this is the y component of the weight. How do we figure out how much is going to this direction, how much is going to the y direction? Well, it depends on this angle here. Okay, so how is this angle related to this? to explain that, let me draw the triangle here so I can show you how we analyze this. This is a triangle of this part here. Okay, I know my weight is going in this direction. This is the angle, let's say this is angle theta. And my normal force go in this direction. Okay, and I wanted to decompose my way into the component, and I say the component is going to be the component along the slope here, and I also have another component which will be perpendicular to that, and that perpendicular will be the same as the m direction. And you can see this one here is a triangle. This triangle will be similar to the triangle of the red color one. But I would need to know what this angle represent at here. Do you think the angle will be equal to the angle of this one or be equal to the angle of this one? The answer is going to be this one here.
Yes.
Okay, and the reason is this. If you look at this as a triangle, right? So we know triangle is 180 degree. This is a 90 degree. So this angle plus this angle is going to be 90 degree. And over here, this is a perpendicular to each other, and here. So this angle plus this angle has to be 90 degrees. Therefore, this angle has to be the same angle as this theta over here. Now the question is, how do you know W2x and W2y? So if I know this is a little bit complicated, but I have to show you how this is working. I'm going to draw a triangle of this part here. Okay, this is a triangle over here. Okay, this is your hypotenuse, which is W2. This is the angle theta. This is the W2y. And this one here is W2x. So what is the W2x? It's the opposite side of the angle, which you will give this one to be W2 sine theta. This one is the adjacent side of the angle, which you will give you W2 times cosine theta. Okay, so if you couldn't get it right now, you can watch this video and think about this again. This is probably the most complicated problem in this chapter. So you have to identify what other component at the different direction in this way. Alright, so once I identify this, what is the next thing I wanted to do? I actually tried to write this two equation. I wanted to write this equation and this equation. So let's look at the x direction first. What is the x direction? X direction is the direction along this direction. If I scroll up again a little bit, then you can see what are the forces on the x direction. Okay, let's write it in here. Let's write it at here. In the x direction, I make this side going right to the positive, and if I start with the t here, this t will be negative t because it goes to the opposite direction. Do I have another force at the x direction? Well, what about this?
Yes.
Right? That is another force. This is a positive. And that's it. That's only two forces acting on this object. And I am going to have the M2 times A. Okay. Now, and you know this one that we said this one is going to be W2 sine theta. So that's one equation. The second equation is to look at the y direction and make it equal to 0. So what are the forces acting on the y direction? You have a normal force. You have a force that is this one here. Are they going to the same direction? The normal force going against the block. The weight of 2 go against the block, go against the ramp. So they are in the opposite direction. So which one is positive? N is positive. And the other one is the W2Y. And that will be equal to 0. And we know W2Y is the W2 cosine theta. So these two are the equation of motion for the block 2. Okay, then the rest of the thing will depend on what the question is asking for. Then you can solve the problem. Let me take a look at this. Alright, the first question they said is, what about the M1, M2, they are in equilibrium, and that equilibrium meaning no acceleration. And can we find the result? Okay, so let me just write that. Okay, A, if acceleration equal to 0, I wanted to find out what is the M1 equal to. And how do we solve this? Well, you have to look at the equation of motion. So I have an equation of motion over here. The first equation of motion is this one here. The block 2 only have one equation. So for block, is it 1 or 2? I don't remember. That's block 1. For block 1, I have T minus W1 equal to what? Equal to 0. Because
Sure.
they are in equilibrium.
Yeah.
Okay? Now, do I know W1? No, that's the thing I try to find out, because T will be equal to W1, which is equal to M1 times G. And I try to find this. And let's look at the block 2. The block 2, you have these two equations. Okay, so I have negative T equal to W2 sine theta. They give you W2, and we know it's 19 kilogram times G, and times the cosine theta. they also give you the angle. In this case, my problem here is 31 degree. Okay, so what does this tell you? This one actually tell you what is the t, right? They give you the t. Okay, so that is the first thing that you can find out. You can get t. All right, we also have another equation, which is this equation that
Oh,
gives
okay.
you 0, right?
Yeah.
So that tells you my n equal to W2 cosine theta, which is equal to M2 times 9.81 times cosine 31 degree. Did I do something wrong? This should be, oh, this should be sine theta. Okay, I'm sorry, this one should be sine angle.
Mm.
This should be sine. Okay, so what does this one tells you? Well, if you find out the t and you can actually put t at here, you will be able to find m1. So by putting this t back into this equation, and because t, this is a t, so t is equal to this, so you can find out what the n1 value is because g is 9.8.
Mm-hmm.
Okay. And what does the second question give you? The second question actually give you the m, because you once you find out the m2, and it will, well, n2 is given. I know this one is 19, so this one times this one times this one give you what the m force is. So we can either ask you this one, or we can ask you tension force, or we can ask you the mass of what as well. Okay, any question about this?
Will this ever be on the exam? Like this exact problem?
It could be. That will be the most complicated one.